Hi everyone, myself Konda Krishnudu, Assistant Professor of Physics, Department of Science and Humanities, MLR Institute of Technology, Hyderabad. So in the previous session, we discussed about helium neon laser, which is a 4-level gas laser, which is capable of emitting continuous output. Because of that, it has so many applications in the field of science and technology. Today, in continuation to that, I am going to explain about one more important laser, that is ruby laser. Now coming to today's presentation overview, today I am going to explain particularly about ruby laser, its introduction, construction, working, using energy level diagram, and then finally applications. After that, conclusion. Now coming to the introduction, ruby laser. So ruby laser is the first laser which is discovered among all, and it is devised by the scientist Theodore Maiman in the year 1960. So actually during 1950s, masers were developed. MASCR, maser. So maser is nothing but a device which is capable of amplifying microwaves. Maser stands for microwave amplification by stimulated emission of radiation. After masers, lasers came into picture during 1960s. During that period, the first laser that is developed is ruby laser. So ruby laser is actually a solid state laser. So why ruby laser is called a solid state laser? Because ruby rod is used as ruby rod is used as active medium in this case. Ruby rod is actually a solid. That's why ruby laser is called solid state laser, and it is a 3-level laser. 3-level laser. Because of that, it is capable of producing pulsed output. Ruby laser gives pulsed output. Ruby laser gives output in the visible region. So output wavelength from ruby laser is 6943 angstroms or 694.3 nanometers. 6943 angstroms. So this wavelength corresponds to visible region of the electromagnetic spectrum. So this wavelength particularly comes under red color. So red color radiation comes out from ruby laser. In ruby laser, optical pumping is used. So we know pumping is nothing but by giving energy from the external source, sending particles from ground state to excited state in order to achieve population inversion. There are so many types of pumping. Among them, the method of pumping we are using here is optical pumping. Optical pumping is nothing but sending particles from lower level to high level by giving energy in the form of light. By giving energy in the form of light, we can stimulate particles from ground state to excited state. That is why you can say that in the case of ruby laser, optical pumping mechanism is used with the help of this source of energy. Source of energy in the case of ruby laser is xenon flash tube. So xenon flash tube supplies the required energy to the particles of ground state so that they will move from ground state to excited state. So ruby laser consists of 3 important elements. Any laser consists of 3 elements, we know. One is source of energy. The second one is active medium or laser medium. The third one is resonating cavity or optical resonator. So any kind of laser possesses these 3 parts. Now coming to the construction. So block diagram of the ruby laser is shown here. This is ruby laser. So in this ruby laser, there will be a glass tube. So this is glass tube. Inside the glass tube, there will be ruby rod. Ruby rod is used as active medium in this case. Single crystal of ruby. Single crystal of ruby or ruby rod is used as active medium. We know active medium is nothing but the medium in which there exists energy levels which are required for lasing action. All that process will take place inside the active medium only. In this case, active medium is ruby rod. Ruby rod is nothing but Al2O3. So to get required energy levels, we need to add chromium atoms. Cr3 plus. We need to add small proportion of chromium atoms to aluminum atoms. 0.05% of chromium atoms will be added as dopants to aluminum oxide, so that the required energy levels will create to get a laser beam from the active medium. Even though there exists aluminum atoms in this case, active atomic centers here are chromium atoms. So between the energy levels of chromium only we are going to get laser transitions. That's why chromium ions are active ions in this case. This is about the experimental rod or active medium, which is kept inside the glass tube or along the axis of the xenon flash tube. So just by seeing this, we can say xenon flash tube is surrounding this glass tube. Xenon flash tube is surrounding this glass tube, and which is connected to the power supply. So when we switch on the power supply, xenon flash tube will glow. Okay, now so xenon flash tube will give white color radiation. So by taking the energy from that, atoms, chromium atoms will move from lower energy level to higher energy level. So this is source of energy here, that is xenon flash tube. Xenon flash tube. Active medium is ruby rod, which is nothing but the combination of aluminum oxide and chromium oxide. Active atoms here are chromium ions. The third one is resonating cavity. So there is no separate resonating cavity arrangement in this case. Ruby rod itself acts as optical resonator because it has two mirrors. On one side it has fully reflective mirror, on the other side it is having partially reflective mirror. So the ends of the ruby rod are polished to a high degree of accuracy, so that one side will act as a fully reflector, on the other side it acts as partial reflector, and the ruby rod with two mirrors itself acts as resonating cavity in this laser. That is about the three important parts of the ruby laser. Now coming to the working. So working, we are going to discuss about or taking energy level diagram. So this is energy level diagram for ruby laser. These are the energy levels of chromium. Between the energy levels of chromium only we are going to get laser transitions, because chromium ions are active ions in this case. This is ground state and these are the two excited states. So initially the chromium atoms will be in ground state. When we switch on the power supply, xenon flash tube will glow. It will emit white color radiation. From that, the particles will receive energy. Based on the amount of energy they receive, they will make a transition to this energy level as well as this energy. These two energy levels are called excited states. Excitation of chromium atoms takes place from ground state to the two excited states given here based on the amount of energy they receive. Some atoms will move from ground state to this energy level. Some other atoms will move from ground state to this energy level. This is called blue absorption and this is called green absorption. So those who will receive more energy, they will move here in this energy level, and those particles will receive less energy comparatively will go to this energy level. So anyway, finally the particles will occupy, chromium atoms will occupy the excited states here. So we know excited states having a smaller lifetime, around 10 power minus 8 seconds. After 10 power minus 8 seconds, automatically they will move to the lower energy state called metastable state here. So these are the non-radiative transitions from excited states to the metastable state. So metastable state is the excited state having longer lifetime. Metastable state possesses longer lifetime. Because of that, these chromium atoms will stay more time here, and accumulation of chromium atoms takes place in the metastable state. At one moment, the population in metastable state becomes greater than the population of the ground state. In that situation, all chromium atoms comes to the ground state and will produce many number of photons. These photons will suffer multiple reflections between the mirrors of resonating cavity, and finally after getting sufficient strength, they will come out as a laser beam from the partially transparent side of the laser device. So this is partially transparent mirror. Through this only the laser beam will come out, having wavelength 6943 angstroms, which falls in the visible region of the electromagnetic spectrum. Red color radiation will come out from ruby laser. So that is how ruby laser will work. So this is what we discussed just now, the procedure of working, how laser emission takes place here. Coming to the applications, ruby laser has so many applications in various fields of science and technology. The first and foremost application of ruby laser is that they are used in the material processing. Material processing means they are used for drilling, cutting, welding, marking, and some other types of material processing, especially with metals. So the red color radiation coming out from ruby laser makes them to use in material processing. The second most application of this ruby laser is medical application. They are used in the field of medicine. Particularly they are used in ophthalmology. Ophthalmology, they are used for laser eye surgery. And they are also used in the skin treatment like tattoos and hair removal. So like that ruby laser also find application in the field of medicine, and even they are used in printing. Printers they are used. They will provide light source. So in printers we use it to see light source, which is used to take the photocopy. So that light source here is nothing but the ruby laser. They are used ruby laser. And next, instrumentation. Ruby lasers are used in Doppler velocimetry to measure fluid flow or fluid velocities. Right. Next, they are used in range finding. They are used in optical range finding. They are used in lidars. They are used in light detection and ranging systems. Ruby lasers also find their applications in the field of research because of the Q switching and mode locking techniques. And finally, even ruby lasers are also find applications in the field of 3D imaging, that is called holography. So it is due to its good coherence properties. Coherence is nothing but coordination among the light waves which are emitted from the light beam. So that is how ruby laser plays an important role, and it has so many applications in almost every field of science and technology. So that is about today's session, where we discussed about ruby laser. Ruby laser is a 3-level solid state laser. It is capable of producing pulsed output because it is a 3-level laser, and high pumping powers are required here to send particle from lower level to higher level. There will be a time gap. That is why population inversion condition is not maintained continuously in this case. That is why a pulsed output is possible with some milliseconds duration. In continuation to this, in the next class we are going to discuss about applications of lasers in various fields of science and technology. So far we discussed about different types of lasers and their applications in specific, but coming to the overall applications of lasers, vast number of applications are there in different fields of science technology. So that we are going to discuss in the next session. Thank you.